Okay, so we are in Chapter 3, Section 4 for IM1. This is called Direct Variation. So we just got through the rate of change in slope section, and now we're going to start to apply that to direct variation. So there's a couple of review items they want us to look at over here. So adding and subtracting integers and multiplying negatives. So it just says review marked with this little asterisk, this little star. So same sign, if we're adding and subtracting integers and they're the same sign, that means both positive, both negative, then you add and you keep that sign. So here's some examples. 4 plus 2, that's 6. Or negative 4 plus negative 2. Still 6, but now it's negative 6. We just keep that negative sign there. Which was... I like my colors here. All right. This is the same as negative 4 minus 2. So we don't really need this plus sign is what it's saying. Okay. That would be the exact same thing, negative 6. So if they're different signs, one is positive and one is negative, then you subtract and the bigger number decides the sign. So negative 4 plus 2. Negative 4 is bigger, or 4 in general is bigger than 2. So the negative wins, our answer is negative. You can also think of that as I have more negative than positives. So when I kind of cancel them out, then I'm left over with them. And I can even draw this over here. I have negative 4. So here's 1, 1, 1, 1. It's all negatives. And here are my positive ones. I didn't do different colors in this one. It was just negative and positive. But I would cancel them out and see what's left over. I have 2 negatives. So that's the idea of that guy. 4 minus 2 equals 2. So that's usually a little easier for students to visualize because it's kind of the regular or the way we learned it back in elementary school is, just 4 minus 2, and that's 2. So that's usually doesn't throw students off as badly. But it would be the same thing here. Instead I have plus, 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 negative, negative. I still cancel 2 and I'm left with 2 positives. So it's still the same kind of visual if we look at algebra tiles there. Multiplying negatives, I think is what it should have said. Multiplying or dividing 2 negative numbers gives a positive. Okay? So that's just reviewing really quick. If you're multiplying or dividing 2 negative numbers, then you get a positive. That does not mean subtracting 2 numbers. This does not give you a positive number. This negative 4 minus 2. That's subtraction. It's only when you're multiplying or dividing. Alright, so let's go ahead and take a look at direct variation. The equation y equals kx, where k is not 0, so this is just a new variable we're being given specifically for this equation, and it can't be 0 in this situation. And this is called the constant of variation, which we can also think of as the slope, okay, or we can call it the constant of proportionality also. And I'm going through, this is what different ways that it can refer to it on Alex and different ways that it refers to it in the book. Proportionality. But really, we can call this the slope. That's what the constant of variation really is. It's how quickly is it going up? What's the change? All right? So it's just kind of a new way to think of slope, like we were looking in the last section. Whoops, didn't mean to zoom in there. That's all right, though. We'll just scooch up. All right. So the bottom part here is just filling in a couple more blanks. So direct variation have to go through the center of the graph, which has coordinates 0, 0. So this is a rule. We need this guy. If it doesn't go through 0, 0, it is not a direct variation. Doesn't mean it doesn't have a pattern or that it's not a line. It just means it's not a direct variation. Because that means we have a starting point other than 0. So we need to have our starting point being 0, basically. Okay? All right, let's go to the next page here so we can see. Did I end up with 2 of those? I did. All right, next one. Let's scooch down here. So name the constant of variation for y equals 1/4 x. Then find the slope of the line that passes through 0, 0, and 4, 1 points, 2 points on the line. So constant of variation, remember, it's y equals kx. That was our equation we were just given for direct variation. And this is y equals 1/4 x. So 1/4 is our constant of variation. And slope, remember slope is the difference in y's over the difference in x's. So if we have 0.2 and 0.1, x2, y2, and 0.1, here's x1, y1. I'm just labeling them. Remember, all this means is this is the x-coordinate for 0.1. This is the y-coordinate for 0.1. That's what x1, y1 means. Same thing with the 2's. X-coordinate for 0.2, y-coordinate for 0.2. Let's set up our little fraction here. So remember, we subtract y2 from y1 on the top, and then x2 from x1. So y2 is 1. I'm just grabbing that right from here. It's right. Y2 is labeled right below 1. And then x2 is 4. And I'm doing that all at the same time just so I don't have to keep switching colors. Sorry. Y1 is 0. And x1 is also 0. So I filled in my pieces before, doing any of the other bits. Let's see. All right, so 1 minus 0 is 1. 4 minus 0 is 4. So it's the same thing. All they're doing is having us connect the idea that the constant of variation is the slope. All right, just like I was just saying on that last page. It's just another way to think of slope. All right, suppose y varies directly with x, and y is 10 when x is 1. What equation would relate x and y? What is the value of y when x is 10? Woof, that's a lot. They're kind of giving us a bunch there. So we need to break this down a little bit. So first, we're given this, dang it, I crossed it off, I didn't mean to. We're given this sentence here, so I keep crossing it off. There we go. Let's see, let's go through here nicely. All right, so suppose y varies directly with x. So when I hear this varies directly with that, it doesn't matter what it is. I'm saying this and that because it doesn't matter if it's y and x or z and a. It doesn't matter. We write it as y varies directly with x. That's the equation. That's how we say this. So this equation works for this purpose. So this would be our equation. But we need to find our constant of variation is the problem. So this is just the basic equation before we have filled any pieces in. So the next part they give us is, and I'm going to focus in on this guy. So y is 10 when x is 1. Sorry, and I wanted to x. When x is 1. So y is 10. They just told us that. I'm going to color this guy up a little bit. So x is 10. So that we can kind of see it happening over here. So y is 10. And equals k. We don't know what the constant of variation is here yet. We get to find that right now. But we do know that x is 1. All right? So now, if I did this, anything times 1 is itself, right? That's not really going to change anything. So this really is just k equals 10. Well, happy day. Now I know what the constant of variation is, or the slope. The change in x's over y is going to be 10. And it's 10 over 1. Remember, it is a fraction, but we don't need to put the 1 in there when we're putting in the equation. So we want to put this back into the equation here. And I'm going to write y equals 10x. This is our first answer. This is our equation. So equation for direct variation. Okay, that's our equation. So now we've answered this question. What's the equation that would relate x and y? And I went too far there. Paying too much attention to the other piece there. So the last piece we need to do is answer this question. Now that we know, and I'm gonna try to do that a little better, but still kind of failed at it a little bit. There we go. Ooh. Oh, and I still got the wet. So what is the value of y when x is 9? All right, well, we know what the constant variation is. Once you know what the slope is, it's not going to change. It's going to be constant. That's why we call it the constant. So now I can plug in y's, or I can plug in x's to see what the other what effect it'll have on the other piece there. So I'm going to use this, and I say, so we don't know what the value of y is. So y equals 10. We do know what the value of x is going to be now. It's going to be 9. So when x is 9, y is 90, right? 10 times 9 is 90. So we just had to kind of work through that one. I know it's a little bit weird when they give us these kind of very wordy word problems. It's kind of a funny way to say it, but we just need to break it down into little pieces. Okay, we're going to look at this next piece. Scooch down a little bit. And this, so we have 2 more problems here. Identify the following as examples and non-examples of direct variation. So remember, 2 things. Are x and y values changing consistently? So do we see a line that's going straight up and down? And then if it's not, or do we see points? So we actually get both. We get to see the line here, and we're going to put the points in the table. Or we have a coordinate grid here that's blank, and we have the points here so we can graph it. So we want to make sure that they're changing consistently. And that just means a straight line. So it's not, we don't want to see anything like this, like a curve, or if we see anything along those lines, that's not a direct variation. We want to see a nice straight line like this. And then the second piece is, does the graph pass through 0, 0? Remember, that needs to be our starting point. We can't start at another number, or the direct variation it's changed. Doesn't mean it doesn't have a pattern. Doesn't mean it's not a straight line. Just means it's not a direct variation. All right, so changing consistently. I can see that right here. That's a very straight line. So I can even check that off, and I'll change my colors here just so that it's easy to see. So checked off for that first one. Yay! We're good to go. And I can put the points in here. I know it's a little blurry, but that first one is 0, -1, 1, 1, 2, 3, and the last one, which doesn't look like we were given part of the table for, but we can draw it in here. Boop, there we go. So 3, 5. So right away, I should notice it does not go through 0, 0. It does not go right through the center of the graph. So it does not meet this guideline. So not a direct variation. Now, as soon as I noticed that, do I need to even pay attention to whether or not the points are changing consistently? No. As soon as I noticed it wasn't going through the center, I can say it's not a direct variation. Or as soon as I noticed that the values are not changing consistently, that, it's either got a curve or it's, doing something like this, if that's not consistent, it needs to be a straight line like that in order to be a direct variation. So with this guy, we are starting at 0, 0. Yay. That's a good one. Here, let's change so I can do my check marks here. So we're starting at 0, 0. So that means, boom, we passed that test. And then the next one, we're going up, or over 1, up 3. And then the next one, we're going over to 2 and up 6. Like that. And if I use my line tool here, so I have a nice straight line, that is very consistent looking. Yay! So those did pass right through each other. That is definitely consistent. So yes. Direct variation. I'm not sure. On Alex, you might have to describe the reasons. So you might literally choose yes, it has a constant rate of, constant variation, or a constant rate of change, and then it passes through the center of the graph. You may have to select down different options on there. You won't have to type anything in. Keep in mind whenever we're putting words in Alex, it's going to be some kind of drop-down menu because we're not checking your spelling on there, and neither is the program. We're checking to see if you chose the right answer. The only thing you ever have to type in Alex is equations or numbers. All right, so we're going to go to number 3 here. Suppose y varies directly with x. Remember, this directly vary with that. Varies directly with that. I think I said that funny, but so we have y varies directly with x. That's exactly what it means. So this varies directly with that. Okay, it doesn't matter what the first and the second one are, as long as you just know that it goes in this pattern. When I hear this varies directly with that, I just plug them in here. Okay, it's pretty quick and easy that way, and hopefully that helps you keep it straight. So now we have y is 98 and x is 14. So they're giving us these so that we can find our constant. All right, so we're going to plug in 98, and then that's going to equal k times 14. So this one's not quite as nice as this one up here. It's not just going to disappear. We do actually have to solve this. So we're multiplying by 14. I'm going to divide by 14 on both sides. 14 divided by 14 cancels. And we have 98 divided by 14. Let's see, what's 98 divided by 14? Oh, 7. So that goes in evenly. So that is 7. So we end up with 7 equals k. So this is our constant of variation. So it wants you to write a direct variation equation that relates x and y. That's our first task, which is what we kind of jumped on right away. I started writing that very quickly before I should have read the entire problem. That's actually a no-no. Being a teacher, I knew exactly where we were going with this, and I've done this problem a few times. But as a student, make sure you read the whole problem before we just start jumping into it to make sure that we're doing it correctly. So that was a bad modeling situation there, but I'm correcting myself now. We want to read the whole problem. So we're going to write a direct variation that relates x and y, and then we're going to find y when x is negative 4. So now I can plug this guy back in, and I'll have y equals 7x. So here is my equation. That's my first answer. My second answer, I'm going to plug x in and see what y is when x is negative 4. So y equals 7 times negative 4. Instead of x, I'm plugging in negative 4 here. This is a negative, this is a multiplication sign. So y equals negative 28. That's my second answer. So I have 2 answers on this one. All right, so that is all of section 4, and I will see you in section 5.